Stan Gibilisco here, proprietor and operator of amateur radio station W1GV Whiskey 1. Good vibrations, to talk a little bit more about Moonbounce or EME, Earth Moon Earth communications, and to describe a little effect that you're not likely to notice until it happens. And that is what happens when the moon, the earth, and the sun all lie along the same line. Now that happens particularly during what they call eclipse seasons, which occur once every 6 months. It depends upon, and it goes in a cycle, 6 months, but it rotates around the year, sort of like a lot of cycles go. But when the moon is in the new phase, that is to say, you don't see it because it's so close to the sun, there's a peculiar phenomenon that will occur that may actually make moonbounce communication impossible for a period of time lasting about an hour as the moon moves slowly around the earth and passes this point where it reaches conjunction with the sun. They call this inferior conjunction because the moon is closer to the sun than the earth, not by much, 250,000 miles or so here, 93 million miles or so here. But nevertheless, the sun is an excellent broadband RF noise generator, and that noise includes the spectrum commonly used for moonbounce, 144 megahertz, 432 megahertz band, and to some extent even the, not that one, 1296 megahertz band. When you're trying to use EME communications, it's tough enough as it is. And besides libration fading, which I've already talked about, there are other effects. The simple heat noise from the earth and the surroundings can affect how your system works. If your antenna has side lobes, it'll pick up noise on those side lobes, heat noise and other such things. The best type of antenna is a dish antenna or a helical antenna which does not have side lobes, and those are the kinds of radiation patterns that are best. Ones where you concentrate essentially all of the energy into the Earth, Moon, Earth communications circuit. I mean, that's what you're trying to do, isn't it? Why waste energy on side lobes and waste received noise on side lobes? But when the moon lines up or nearly lines up with the sun like this, you're going to hear solar noise in addition to whatever you hear coming back to you from the moon, from another radio ham, or even your own signal. And that solar noise can, in fact, get strong enough to bring the signal-to-noise ratio to the point where you can't hear that signal. It's weak enough as it is. It's right down there in the noise as it is. You elevate the noise, and you're really going to have trouble. So that's something that I call solar noise for lack of a better word. There are other sources of noise, but the sun is probably the most common. I recall when I lived in the Carson Valley in Nevada, having an internet connection that involved wireless satellite communications by means of a dish antenna. Had a lot of issues. It was a long time ago. It was right around the year 2000, and there was a lot of the stuff that happened then that doesn't happen now. But solar noise is always going to happen, at least as long as I'm around, and as long as you're around, and as long as EME is around. And we're going to have this problem every time the moon is in the new phase, but particularly during eclipse seasons when the moon comes the closest to lining up perfectly with the sun. Solar noise renders Moonbounce communications more difficult and perhaps even impossible. You wouldn't think you'd do Moonbounce communications during the daytime, particularly when the moon is nearly in line with the sun. But as long as there's a moon there, and as long as there's an earth here, and as long as the radio hams on both ends of the circuit have the adequate equipment and antennas, it doesn't matter whether it's day or night. That's sometimes doesn't even occur to people to try to communicate by Moonbounce at, say, 2 o'clock in the afternoon, but it can be done just as easily then as at 2 o'clock in the morning. Right now, here in the black holes of Dakota Territory, United States of Amateur Radio, we have nearly a full moon, and it's out right now. And you could imagine very easily Moonbounce communications. Not so 24 hours from now. Of course, it'll be on the other side of the earth. You aren't going to even see it. But not so, say, when the moon is in when the moon is at the quarter phases, and you might see it at 9 a.m., 10 a.m., 2 p.m. You can communicate just as easily then, no matter what phase the moon is in, as long as it doesn't get too close to this broadband noise generator, the sun. Bet that didn't occur to you, did it? Unless you've done a lot of Moonbounce. Then you've experienced it, without a doubt. Stan Gibalisco, W1GV, saying 73 for now. That's best regards in ham radio jargon. And so long, which in Moonbounce communications would probably be did-did-did-da-did-da.